guys, welcome back to another lesson. First of all, please make sure that you turned in your 8.6 polynomial project. You should be able to submit it just directly through Flipgrid, which is opened when you click on the assignment in Canvas. Okay, so today we are talking about complex roots. So if you look at these first three examples, they are parabolas that intersect with the x-axis in different ways. So I'm just going to go ahead and highlight the x-axis in all of these. So on this first one, there's my x-axis. I've got a root at -3. I've got a root at +3. So I've got two separate roots. And if I were to solve for those algebraically, I would just take each of my factors and set them equal to 0. So setting x minus 3 equal to 0 gives me x is equal to 3. X plus 3 equals 0 gives me x is equal to -3. Okay, so there's my first example, two distinct roots, okay, or two single roots. So now if I look here at my second example, once again, I'll highlight my x-axis, which is right here, okay, that has this one root at -3. And if I took my factors and set them equal to 0, x plus 3 equals 0, x equals -3, that is one double root. I'll just write this in over here. This is two single roots. Now we have this third case over here on the right. And if I highlight my x-axis, there are actually no places where my parabola hits the x-axis. So it's a quadratic, so it still must have two roots. Okay, polynomials always have the same number of roots as their degree. But the thing is here, because I can't see anything on the x-axis, that means that there are no real roots, but there are going to be then imaginary roots or complex roots. So you can see on your graph, this is what it looks like. There are still two roots, they're just imaginary. To help solve this, when you are solving, you're going to want to put your calculator in a different mode. So if I pull this up right here, what you want to do is you want to go to mode, and then you want to go down to where you've got these options here, where it says real. Okay, that's where it's blinking right now. Now, when we talk generally, we're talking about real numbers, right? We are going to scroll over to where it says a plus bi. That is what we call a complex number. It's an imaginary number. And you get that when you try to take the square root of something negative. Okay, so now going back. Okay, so we've changed our mode, looks good. What is that? Well, here's the thing. If I go back and I go here, let's try to take the square root of -25. We know that that's an error. You can't take the square root of a negative number, okay? Well, if I go back to my mode, if I quit out of that and go back to my mode, and change this to a plus bi, and then do the same thing, it gives me 5i. Because really, the square root of -25 is the square root of 25 times -1, right? So that I is the square root of -1. That's what it is, all right? So going back here, what is I? I is the square root of -1. And why is it useful? Because if I have something like the square root of -25, then I can change this to be the square root of -1 times the square root of 25, and that will give me 5i. Okay, so that is what I is. So to find complex roots, when we see this, we are just going to solve for roots by setting each of these quadratic equations equal to 0. Put this back down. So if 0 equals x squared plus 25, then I would subtract the 25, or I would subtract the 25. So x squared is equal to negative 25. And then when I take the square root of both sides, I get 5i. Okay, looking at this next example, 0 equals x squared plus 5. I would subtract the 5, so x squared is equal to negative 5. Take the square root of that. 5 is not a perfect square, so what I'm actually going to do here is I am going to leave it as, let me see here, what I really would be doing is the square root of negative 1 times the square root of 5. Square root of negative 1 is I, and square root of positive 5 is just root 5. It's a decimal. I'm just going to leave it like this, so that's my answer. So pause the video right now. See if you can try 2 and 4 on your own. Okay, so you should have gotten these two answers. X equals, oops, I didn't even put that over here. X is equal to this, X is equal to, X equals 9i. Sorry, I just realized I made a mistake on these, guys. Whenever you take the square root, something we tend to forget is you have to remember your plus or minus. So I'm going to go ahead and I'm going to add in plus or minus to all of these. Plus or minus, plus or minus. Let's see, this one needs a little eraser. Okay, so now that you've checked your work and I've checked mine, these are the answers you get, because whenever you're taking the square root of something, you get the positive answer and you get the negative. So we need to do that here, even when we're taking the square root of a negative. Okay, so now looking at these next couple of examples, I note that I cannot actually factor these. If you want to take a minute and try to factor it right now, try it. But these are actually not factorable. So instead, we need to use the quadratic formula. So I can identify, I don't actually have a leading coefficient, so that's like a 1. So I'm going to set it equal to 0 because that's how I find my roots. 0 is equal to 1x squared plus 10x plus 26. And then using the quadratic formula, I have to identify my a, b, and c values. So a is equal to 1, b is equal to 10, and c is equal to 26. Now I'm going to substitute those into the quadratic formula. So x is equal to the opposite of b, so negative 10 plus or minus the square root of b squared, so 10 squared minus 4 times a times c. All of this divided by 2 times a, which is 1. Okay, so pause right now, enter this into your calculator and see what happens. Okay, so when you enter it into your calculator, you should get this. All right, so I entered that entire thing in, making sure my entire numerator was in parentheses. And the problem with this is, if I actually entered just what's underneath the radical into my calculator, and note, I just did the plus part, I didn't do the minus, I'll do that next. If I entered just what's underneath the radical in my calculator, I would get a negative number. So I need to make sure that my mode is in that a plus bi mode. Oopsies. That will give me complex answers. So now when I go back and I try to get it again, I get negative 5 plus I. Okay, so going back here, I get x is equal to negative 5 plus I. Okay, this is what we call a complex root. And the complex root, it's a complex number. It's the combination of an imaginary number and a real number. So I'm taking negative 5 and I'm adding I to that. Okay, or let me see here, if I do the subtraction part, minus, it's negative 5 minus I. Okay, so we've got negative 5 plus or minus I. This will always be the format of these complex numbers. The -5 is the real part. And then you are going to be adding or subtracting some imaginary part. Anything that contains I is imaginary. Okay, so try this next problem on your own right now. Okay, so you should have gotten that x is equal to -4 plus or minus 2i. So that's what a complex number is. And you will see this when you're looking at a graph, when you know it's, let's say you know it's a degree 5, and you can only see 3 of the roots. Then you know you have 3 real roots and 2 imaginary or complex roots. Okay, so that is all for today. If you have any questions, feel free to email me. And once again, make sure that you submitted your summative project. Thanks, guys. Talk to you soon.